Hello everyone, and welcome to this exciting Arduino tutorial. In today's lesson, we will be learning how to control LEDs in a random pattern using the Arduino board. We will explore three different examples, starting from the simplest one, where we turn on a random LED, and gradually moving towards a more advanced LED light show that blinks LEDs randomly to create a cool effect. By the end of this lesson, you will not only understand how to work with arrays in Arduino, but also learn how to use the random function, which allows us to generate unpredictable results, making our projects more dynamic and interactive. Before we begin, just a quick note, make sure your LEDs are connected to the right pins. And remember to use current limiting resistors, like 220 ohms or 330 ohms, to keep the current from getting too high and damaging your LEDs. Remember that LEDs are polarized components, meaning they must be connected in the correct direction. The longer leg should connect to the digital pin through resistors, and the shorter leg should go to ground. Make sure that the ground line to which the shorter leg of the LEDs is connected is the same ground as the Arduino's ground pin. To ensure a clearer view of the connection points and make the circuit setup easier, we test the circuit using the Tinkercad application. This allows us to verify the circuit's overall functionality through simulation before physically assembling it. All three example applications we will implement will be built using the same circuit design. However, they will have different working principles achieved solely through changes in the code. In the first example, we will create a random LED blinking effect where only one LED lights up at a time, changing every half a second. The Arduino controls which LED turns on by sending a high signal to a specific pin while keeping the others low. The 500 milliseconds delay between LED changes allows the effect to be clearly visible. Now, let's take a look at the code and we will examine it line by line. In the first line, we are defining an array called LEDs, which stores the pin numbers of 4 LEDs connected to the Arduino board. Arrays are useful because they allow us to store multiple values in a single variable, making it easier to manage a group of LEDs. We also declare a constant integer variable LED count, which simply holds the number of LEDs in our setup. If we want to add more LEDs, we can simply update the number here. The setup function runs only once when the Arduino starts. Inside this function, we use a for loop to go through each LED in our LEDs array and set it as an output using pin mode. This is necessary because, by default, Arduino pins are set as inputs. If we don't set them as outputs, we won't be able to control the LEDs properly. We could also define each pin as an output one by one, but in that case, we would need to write 4 lines of code. When writing similar code, using a for loop to define them helps keep the code organized and prevents unnecessary clutter. Now, inside the loop function, which runs continuously, we generate a random number using the random function. In this example, there is no need to change the seed value because the built-in random function already creates enough variation to make the LEDs light up in a random and mixed order. The number will be between 0 and 3, which corresponds to the indices of the LEDs in our LEDs array. With this code, each time the loop runs, a different LED may be selected. Before turning on the randomly selected LED, we first ensure that all LEDs are turned off using another for loop. This is important because without this step, multiple LEDs could remain on from previous loops, which is not what we want. After all the LEDs are turned off, we use digital write to turn on the LED at the randomly selected index. Then, we use delay 500 to pause the program for 500 milliseconds, allowing the LED to stay on for a short while before the loop starts again. That's all for the code writing. Let's make sure that all the parentheses are properly closed. Then select the board as Arduino Uno from the Tools menu. And then choose the correct port that your board is connected to. Next, let's compile the code and upload it to the Arduino. When the Arduino is powered on, all LEDs are initially turned off. The Arduino begins executing the loop function, selecting a random LED to turn on. The program generates a random number between 0 and 3. Each number corresponds to one of the 4 LEDs. Before turning on a new LED, the program first turns off all LEDs to ensure that only one LED is on at any time. The process repeats indefinitely, with each LED being selected at random every 500 milliseconds. There is no fixed order. Each cycle, the Arduino picks a new random LED. Sometimes the same LED may light up twice in a row, depending on the random selection. This creates a jumping light effect, where a single LED lights up in a seemingly unpredictable pattern. This application can give you ideas for future projects involving games that you will create using buttons or an XY joystick module. Now, let's move on to the second example application. In this example, the circuit design remains the same, so you don't need to change the design from the previous example. Once again, we see an application where the LEDs turn on and off in a random sequence. In the first program, the LEDs turned on at 500 millisecond intervals, and each LED would light up immediately after the previous one turned off. In this second example, the LEDs will light up sequentially for 200 milliseconds, remain off for 200 milliseconds before the next LED turns on, creating a different LED effect. For this, the LED will turn on and stays on based on the number generated in each loop cycle, and will then remain off for the same duration. Now, let's analyze the program using the Arduino IDE. Since the initial parts are the same as the previous program, I will go through them a bit quickly. First, we create an array to store the pin numbers of the LEDs and define a variable that specifies how many LEDs are being used. This setup is exactly the same as in the previous example. In the setup function, we use a for loop to set each LED pin as an output to ensure that the Arduino can control the LEDs properly. Now, let's move on to the main part of our program, where we control the LEDs dynamically. We start by creating a variable called random LED. This variable will store a randomly selected number that represents one of our LED pins. Next, we use the digital write function to turn on the LED that was randomly chosen. The function takes two arguments. The first argument specifies which LED we want to control, and the second argument tells the Arduino whether to turn it on or off. Here, we use high, which means we are sending an electrical signal to that specific LED, making it light up. After turning on the LED, we use the delay function to pause the program for a brief moment. The number inside the delay function determines how long the program will wait before moving to the next step. In this case, we set the delay to 200 milliseconds, which is about 1/5 of a second. This short delay allows the LED to stay on for a visible amount of time before turning off again. Once the delay is over, we use the digital write function again, but this time we set the LED to low. This means we stop sending electricity to that LED, causing it to turn off. Finally, we add another delay function, once again setting the pause time to 200 milliseconds. This short waiting period ensures that there is a brief gap before the next LED lights up, creating a blinking effect that looks smooth and natural. We are following the same steps as in the previous example. We first select the correct Arduino board and the appropriate port. After that, we compile the code and upload it to the Arduino. When the code is uploaded, the system continuously selects a random LED and briefly turns it on before switching it off again. This process repeats indefinitely, creating a dynamic and unpredictable blinking pattern. The timing remains consistent, ensuring that each LED stays on and off for the same short duration. This creates an interesting blinking pattern where the LEDs turn on and off in a completely random order. And that's how this program works. It continuously selects a random LED, lights it up, turns it off, and then repeats the cycle indefinitely. Since the LEDs change in a random order, it is possible for the same LED to light up multiple times in a row. This randomness can create situations where the same LED turns on again before others have been selected. In the last program, the LEDs will light up and turn off in a completely random pattern. Unlike the previous examples, where a single LED would turn on and off continuously, this time the program selects a random LED and makes it blink for a short, randomly chosen duration. This process repeats 10 times in a row, creating a more dynamic and unpredictable lighting effect. After completing 10 cycles, the system pauses for 1 second before starting the sequence again. This short break helps to create a noticeable separation between each set of random blinks, making the pattern feel more structured while still being unpredictable. Now, let's start analyzing the code using the Arduino IDE program. At the beginning of the code, we define an array that stores the pin numbers of the LEDs. Along with this, we also create a variable that holds the total number of LEDs in our setup. Next, we have the setup function. Inside this function, we use a loop to set each LED pin as an output. This ensures that the LEDs can be turned on and off as needed. In the program up to this point, everything is exactly the same as in the previous programs, so we did not make any changes. Now, let's move on to the loop function, where everything inside will keep repeating in a cycle. Inside the loop function, the first thing we see is another loop that runs 10 times. This means that the next set of instructions will be executed 10 times in a row before moving on. Within this loop, a random LED is selected from our list. The program generates a random number within the range of available LEDs and assigns it to a variable. This number represents the position of an LED in our array. Once an LED is selected, it is turned on. This is done using a command that sends an electrical signal to the corresponding pin, making the LED light up. After turning on the LED, the program pauses for a brief moment. However, instead of waiting for a fixed period like before, the delay time is chosen randomly. The program selects a number between 100 and 500 milliseconds, which means that each LED will stay on for a different amount of time. After the delay, the LED is turned off. This is done by sending a signal to stop the electrical flow to the pin, causing the LED to go dark. This process of selecting an LED, turning it on, waiting for a random time, and then turning it off is repeated 10 times. Once the inner loop completes all 10 cycles, the program introduces a longer pause. This pause lasts for 1 full second before the entire process starts again from the beginning. We again select the board as Arduino Uno and choose the connected port. Let's compile the final example, upload it to the Arduino board, and see how it works in action. First, the program randomly selects one of the LEDs from the list. Then the chosen LED is turned on for a random amount of time, between 100 and 500 milliseconds. After this short period, the LED is turned off. This process repeats 10 times, with a new LED being randomly selected each time. After the 10 cycles, the program waits for 1 second before starting over. As a result, the LEDs light up randomly, staying on for different durations each time. This creates a dynamic and unpredictable blinking sequence. So, by using random, we've created 3 different LED projects. You can improve your programming skills by trying these projects with more LEDs or by using different algorithms to create new effects with the LEDs. See you in our next lessons.